We are trying to build a new type of accelerator, and the reason why we are trying to do this is to try and shrink the sizes of accelerators. Accelerators are typically really large devices. The largest accelerator that you might have heard of is the one in CERN in Geneva. It's around 25 kilometers long. With laser-driven accelerators, there is actually a potential to make them accelerators much cheaper, which means that they are more accessible to end users. So what you can have in a kilometer-long accelerator, or where you need a kilometer-long accelerator, you can in principle do the same thing, accelerate particles to the same energy in a centimeter long plasma.
And this idea caught the imagination of all of us, both from UK and India, and that seeded the idea for coming together for technology, which eventually became the Extreme Photonics Innovation Centre.
So Tata Memorial Centre is one of the biggest cancer hospitals in Asia. If you look at onset of cancer, that typically in a lot of cancer, soft tissue cancer especially, like breast cancer, cancers in kidneys and things like this, in liver for example, cancer onset is typically starts as something called calcification. If you actually use sources driven by laser-driven accelerators, one day it will be possible to actually start looking at the onset of cancer at a very early stage, which obviously will have a huge benefit for the lifetime of the patient.
So once we have this idea, we had a small amount of seed money to try it out, and then based on the success of this, we were encouraged by the UKRI to write for a slightly more expanded funding and increasing the scope of this program, which required mechanical engineering, electronic engineering, digitalization, artificial intelligence, machine learning.
Obviously, a lot of industries, especially aviation industry, where you really want to have high resolution, for example, looking at nano cracks that appear in turbine engines and things like that, which you can't really use conventional technology to have that kind of resolution in imaging. You can actually use laser-driven accelerators for those applications.
In fact, I should of course mention that the collaboration that started with us in the DAE and the RAL at STFC has now flowered into something much bigger. One of the dreams is that we should not only look at first-rate science, but how first-rate science leads to great technology and innovation within the country. So I'm not talking about innovations which are incremental, but innovations which stand on their own as first leaps into some new direction. I think that's something that we are really hoping will happen.